Okay, college algebra, this is a review of the chapter 5 stuff on test 3, which is sections 5.1 and 5.3. Those short little homeworks. So the first one is a system of equations we're solving. Now we're going to do this by elimination. So I'm going to add the 7x to the other side. For the second equation, it's the y that needs to move to the other side. Now, in order to turn one of these into the other, I'm going to have to multiply the first equation by -3 to get -21x minus 12y equals -12. Then if I add those two together, I get 0 equals 0. So this is the situation when we have infinite solutions, because 0 is always equal to 0. How do we put these answers in? This is where we let one of them be the free variable. So it depends what the homework tells you to be the free variable. We're going to let y be the free variable this time, since I'm going to let y be whatever it wants. Now I need an equation solved for x so I can see what it is in terms of y. So I'm going to do that over here. I'm going to divide everything by 21 to see what x is equal to. It's equal to 12 21sts minus 12 21sts y. They reduce. That's 4/7 minus 4/7 y. And I can just slot that in. You can either do 4/7 minus 4/7 y or -4/7 y plus 4/7. Either one of those works. I'm going to do it the second way. -4/7 y plus 4/7. Of course, you could let x be the free variable as well, but I'm letting y be the free variable there. Now, besides systems of equations, we also had matrices. So when it says find what looks like an absolute value, this is really the determinant of the matrix. Remember, the determinant of a 2x2 is the top left to bottom right diagonal first, so 1/2 times -8 minus the other diagonal, -10 times -3/5. Half of -8 is -4. Negative times negative is positive. 3/5 of 10 should be 6, so -4 minus 6, which is -10. That's it. So that's -10, so you could say that the determinant of A is equal to -10. Either one of those is fine. Usually it will have this already on you if it's on a problem, so I would just make sure you see what they already provided you. But I will always go back and give partial credit if something like that happens. Lastly, use Cramers rule to solve the following system. So Cramers rule for a 2x2 is where we've got our original determinant with the coefficients. And we have to find the determinant of that. So we have 3 times -8, which is -24, minus 5 times 6, which is 30. -28 minus 30 is -54. Now to find the x component, dx, so this is really d, dx is replacing the x values with the answers. So -3 and 3 instead of 3 and 6, 5 and -8. So we have -3 times -8 minus 3 times 5. That's 24 minus 15, which is 9. dy. It's the same thing, but instead of replacing the x coefficients, we're replacing the y. So we still have 3 and 6 for x. Instead of 5 and -8, we've got -3 and 3. So we got 3 times 3 minus 6 times -3. That's 9. It's going to be actually plus 18, which is 27. Now again, to find the actual solution, x and y, x is equal to your answer for the determinant of x divided by the original, which in this case is 9 divided by -54. This reduces to -1/6. You do the same thing for y. It's dy over d, which is 27 over negative 54. And that reduces to negative 1/2. Now again, this is a system of equations, so those two should be together in one point. So negative 1/6 and negative 1/2 is the answer. You might think, why would I ever do it this way? It's just a technique. So this is the Chapter 5 practice stuff.